In AC circuits, there are oscillations of voltage and current both, and the power consumption of AC circuit, the strength of AC circuits will be there. It is able to do the work only when we get voltage and current both, because power is equal to current multiplied by potential difference voltage. So both should be there. If either of them is 0, then the power is 0. If voltage is full but the current is 0, how? Answer is, when we connect a circuit with an AC source, there is a phase difference between voltage and current depending upon the values of inductor and capacitor. If there is a phase difference and the voltage is like this but the current is like this, then what will happen? When the voltage is full, the current is 0, and when the current is full, the voltage is 0. Now you multiply here, what do you get? 0. So no work is done. Therefore, it is necessary that we should learn and we should know what should be the relation between V and I, so that we get the power, we get the work done. That means if our fan, we want the fan to run, to work, then it should consume power. We are giving it AC supply, then what is the condition so that fan has sufficient power to work? Similarly, for any motor to work, there is certain condition of potential difference, voltage and current, and their phase between them. And that is what we are going to find. So first we will find it by a derivation, by relations between power, V, I and the phase difference. After that we will find our results. What should we do so that a minimum of potential and current gives us maximum of power in our machines where we are using AC. So let's find out the power. The derivation of power. Power is what? Power, we will find out average power, one cycle of alternating current. To find out this average power, we should know the formula for power. Okay, average. How do we get average of anything? The answer is, average will be the total work done during one cycle divided by the total time consumed in one cycle, because here at any one time, the work done is different, at the other time work done is different, at the other time work done is different, at the other time work done is different. So how we will find the average? Answer, do all these work add up, do calculation for all these works, add them up and then divide it with time. When you divide the total with time, you will get the average. So for average power, we write down how we are going to calculate. One cycle AC is equal to work done during one cycle to be divided by time of one cycle. Okay, work done during one cycle. Work done is equal to E multiplied by I. And during one cycle for one complete time, this is instantaneous value, this is instantaneous value. This will give work done for a very small time. Now we have to multiply it with the small time dt. This is formula for power. When we multiply with time, this is formula for work done for a very small time dt. Then what will be the total work done? Total work done will be integration it 0 to t. This is work done during one cycle. This is work done for an instant. This is work done for full one cycle divided by time of one cycle. This gives what? Average power. And now we have to solve it. Integration 0 to t. This 1 upon t I will write here. Let it be here, and this we will do integration of E into I into dt. E is equal to E naught sine omega t, and I is equal to I naught sine omega t. Both may not be at the same phase. There may be a phase difference of phi. So let me write phi. So this is instantaneous E, that is instantaneous I. These two are to be multiplied with a small time dt. Okay, now this is equal to, for doing integration, these two are the constants, they come out E naught I naught, and what we have here is sine omega t multiplied by sine omega t plus phi into dt. So sine omega t and sine a plus b is equal to sine a cos b plus cos a sine b. So I will write it sine omega t cos phi plus cos omega t sine phi. So when we open this, one thing remember, what is phi? Phi is the phase difference. Omega t, phase at any time. Out of these two, one is variable, one is constant. What is variable? The one which is multiplied with t, because when the t changes from 1, 2, 3, 4, 5 seconds, omega t will keep on changing. Phi is a constant phase difference. So this is a constant, this is a constant term, and these two are variable terms. Anyway, dt. Now we open this bracket, and what we get here is sine square omega t cos phi plus sine phi, and this is sine omega t cos omega t. And this whole dt. This is sine 2 omega t divided by 2, okay, dt cos phi integration 0 to t sine square omega t multiplied by dt. This, now we integrate them. Okay, we have done one integration when we were looking for average value of I. At that time I told you we will need it again. What was that? That was integration of sine square omega t dt from 0 to t, and at that time we have derived it, we have found it, then we remember it that this whole thing is equal to t by 2. So this is cos phi t divided by 2. Because this we already know that this is equal to t by 2. We have done it. If you want, you can see the previous lecture or you can do it yourself. So this is t by 2 plus sine phi upon 2 integration of sine theta is equal to cos theta. So we will write it cos 2 omega t divided by 2 omega, this 2 omega, and the limits are 0 to t, minus 1 upon 2 omega, and here 2 omega is equal to 4 pi upon t, because omega is equal to 2 pi upon capital T. So this we can write as cos 4 pi into t. So for once we will write it t, 4 pi upon t multiplied by, in place of this t, minus again cos 4 pi upon T multiplied by 0. Now this is equal to this, and here cos 4 pi. Cos 4 pi is equal to 1, and here this is 4 pi T into 0 is equal to cos 0, that is again 1. So 1 minus 1 is 0 in the bracket. Okay, this 0 in the bracket makes it 0, The whole term, this becomes 0. So what remains here is E naught, I naught, T by 2 and into cos phi, and the whole thing, there was this T going on from the very beginning. Okay, so it is this. This is equal to, here T is cancelled. This is 1 upon 2. We divide it into two parts, root 2. So we can write it E naught upon root 2 multiplied by I naught upon root 2. This 2 into cos phi. Now we know that peak value upon root 2. E naught upon root 2 is E RMS, I RMS and cos phi. What is phi? From the very beginning we have told that phi is the phase difference between E and I. When equation of E is E naught sin omega t, equation of I is I naught sin omega t plus minus phi. That is the phase difference. And this formula is for what? This is average power during one cycle. So this is average power during one cycle. Virtually, how do we calculate power? Answer, we simply multiply it by V into I. That is what we have learned, the formula for power. In electricity is instantaneous value of E and instantaneous value of I. So these two are different. So this is the formula which appear to us. So we call it apparent. You see, cos phi is the phase difference between voltage and current. Now we have to multiply the two. If we set the timing in such a way that this peak comes under this. This is current I. Then what will happen? Then the power will be maximum, no phase difference. But if the current is in such a way that here is the peak and here is the zero, this is the current, then what will happen? We see that this is V, this is I, and their multiplication is 0. So V is same, I is same, but there is a certain difference in their placement like this. If there is a difference in their placement, that means we are making I slightly delayed. This delay is maybe due to inductor, this delay may be due to capacitor. So if there is a delay between V and I, then their multiplication may not come the full value, it will be less than that. And who decides that? This formula what we have made, that is E into I into cos phi. If there is absolutely no difference between them, then phi, the phase difference is 0 and cos 0 is equal to 1. And that gives us the full power. So this is the value of apparent power, we call it, and real power. Real power is the one which we have made the formula, E I cos phi. If we don't write anything here, it means it is effective value. Effective value is RMS value. So let's not write anything. So apparent power E into I, real power EI cos phi. Now if we see the relation between the two, this we will see in the next lecture, and how power, this, what is this cos phi, what is its name, how it is effective, this we will discuss in the next lecture. So far we have seen that real power is this and virtual power is this. Thank you.